Welcome to the last part of linear regression lecture, in which we will wind it up and also show its implementation. But let me briefly recall first the mathematical formulation of linear regression. The input is denoted by x1, x2 up to xn. These are also called features. The output by y, and weight corresponding to each xi we denote by theta I. That is, the input output relationship can be written as theta 0 plus summation I is equal to 1 to n theta I xi. And if we denote x0, if we define x0 to be 1 always, then we can even merge this theta 0 term also in the summation. Now if we define the vectors like this, theta and x vector, so theta vector like theta 0 to theta n are the elements, and x0, x1, xn are the elements of vector x, then we can write this relationship in this form, theta transpose x. Now, as I told in last lecture, this theta transpose x is what? Suppose if someone tells you the values of x, and someone tells you the values of theta, x is the input. Let's say the CGP example, x is the vector which denotes the grades and CGP of a student. Then what will be your hypothesis about, say, the average package CTC of the student? So hence we denote this also as h theta of x. So this is also called the hypothesis function. In fact, as y is not proper, we should write y hat. Basically, this is the estimate of the output. Okay, the actual output will be given in the data set. Now let's again recall what is data set. Data set by letter D. So here is the data set. So x1 of 1. So the superscript at top, this one. Okay, it basically denotes the suppose if we are dealing with the CGPA case, then it means that this particular full tuple, it is the data of student number 1. Okay, that is the grade of student number 1 in one subject is x1, x2 of 1 in another subject, and xn of 1 may denote the CGPA. Y superscript 1 is, let's say, the average CTC of student number 1. Similarly, in between I have picked up here student number j, and at the end, let's say there are m such entries. Okay, and as I told, this whole will be the training data set. That is where all of them, all the values are known. This is the given data set. Okay, we know the placement record of the students. Now what is your guess, or what is your estimate, or what is your hypothesis about CTC of a student? So given now a vector for student j is like this, x vector. It means the grade of student number j. Okay, the first one is 0. So remember that x0 for all students is 1. Now the grade of first subject of jth student is this x1 of j, and the grade or the CGP of jth student is xn. So this is the vector xj. Given this, what is our hypothesis? That is denoted by h theta of xj. This is our hypothesis, which is given by theta transpose xj. Okay, and if you expand it, then it will become summation I is equal to 0 to n theta I x j I, like this. Notation little bit becomes messy, but it is not anything hard again. Now this is your hypothesis or estimate of output. Now what is the actual output for jth student? Suppose yj. Now what will be the error? So h theta of xj minus yj. Now what will be its average? J is equal to 1 to m square, mean square, and here is the mean m, and I will put here 2m because when I find the derivative, then at that time it becomes easy. And this whole is denoted by j of theta, and this is called your cost function. or loss function. Fine. Since the square we know that it is a convex function and our goal is to minimize this j of theta with respect to this theta value, right? Now we will not go into details. For one input case, we have rigorously derived that what will be the value of these weights in terms of input. But for general case, we will not do it. You can easily do it. Basically, you have to find the gradient of this with respect to theta and put that equal to 0. That is, you have to find partial derivative of this loss function with respect to theta 0, theta 1, put equal to 0. Now, we need to implement it in Python. For that, what is the first thing you need? We first need dataset. Okay, so I have created a dummy dataset file in Excel. I will show it now. See, here is a dummy dataset file. So let's say this is the record of last 4-5 years placement data. Like this is here the enrollment number of student. Then x1, x2, x3. Suppose x1 is subject programming in C, x2 is subject Python programming, x3 is subject probability and statistics, x4 may be signal system, communication system, electronic devices, VLSI design, mathematics 1, mathematics 2, control system, so on so forth. So I have here suppose 39 subjects, 40 subjects. Then there is a CGPA. Okay, so here is a CGPA calculated, and then there is average CTC in lakhs per annum. Okay, so here is the average CTC. Fine. And what is the size of my data set? So let's see. I think it is 2000 students we have here. Okay, so we can see 2000 student data set I have created here. I will share this file with you people also as a dummy data set. But if you get the real data set from academic section, it will be almost similar. Now let's try to find relationship between the input and output. What is input here? The grade and CGPA. And what is the output? What is the average package a student has got of the placement. Now the first job here, suppose if you are using any Python IDE, that is your Python editor is installed on your laptop, that is you don't need internet connection for running the Python, then it's very easy to load this file there. I will show you how. But if in case most of you are using Jupyter notebook, now I will first show you how to upload this file to the Jupyter notebook. So here we are. Click on the Jupyter notebook, and then in view, go to the file browser. Here is the file browser. Now I need to upload this file from a computer, so I will click here upload. And I have here two files. So this one is placement dataset updated. I will open it, and it got uploaded here. Notice that it is CSV version, CSV extension. CSV file is sort of it's an Excel file, but its size will be very less. It has less formatting, we can say issues as compared to the Excel sheet. So it is almost same as Excel file, but it will not have, like in Excel you can have sheets and other things, and you can have, in addition to simple text and numbers, you can have other objects. So CSV file is a very compact version of that. So you can go to Wikipedia to learn more about it. Its full form is comma separated values, in which is a text file, but in which commas are used to separate the values. So you can look into the details here. For us, it is very simple that it is as good as Excel file, simplified Excel file. Now we have uploaded this in the Jupyter. You can see our cloud space is here. Now let's open the Jupyter, browser. Sorry, Jupyter command line. So here I am selecting new console. Now to we have uploaded this file. Now to read this file and store the file in our Python as something called data frame, you will use a package which is called Pandas package. Import Pandas as PD. Okay, so you can write pd dot and tab, and there you will see it has lot of different functions here. So which function we need? We need to read CSV file. See here, there is a read CSV. So you can write pd.read CSV, and then we need to enter the address for this. So we'll now write the name here. What is the name of file? It is placement dataset updated. Now let me press enter. So here it is. You see it displays the complete entries here, but it will not show all. So it has started with 0, 1. So data, we call this data frame, this whole thing. So data frame is a new entity in Python, which is not there in other languages like C, C++. In fact, let me rerun it. So I will load this CSV file and save it in data frame, which is called df. Okay, now if I write df, you see this whole thing got saved here. What is data frame at the outset? So you can think of, whenever you load any file, whether Excel file or CSV file, when you save it in Python, by default it is saved as data frame. That is whatever is in the file. Suppose we have here different columns, different rows, the whole entity, it saves as a data frame. Now we need to access the data of the data frame. So in data frame you have columns and rows. Now you see I have typed this df.x1. Now you can basically write df dot any column name, suppose x2. So it will display the CGPA in the subject x2. You see 9, 7, 10, 5 here. 9, 7, 10, 5. Now suppose if you save this in another variable x2, fine. Now see x2. So x2 is now a sort of array, okay, with 2000 elements, and this x2 contains now CGPA of all the students obtained, no sorry, grade of all the students obtained in subject x2, which let's say we take x2 as Python programming subject. Okay, similarly you can write df dot CGPA. See, now this you can save in, let's say, x41, because we have 40 variables for grades. So x41 contains now CGPA of all the students, and we have one more variable, suppose average CTC LPA. So we can write like this, let's say y, I will write here y CTC means the average CTC variable. So df dot, this is average CTC LPA, this is the output. Now this y CTC contains the CTC of all the students, 2000 students till past 4 or 5 years. Now suppose you want to extract multiple columns, okay, then what will we do? df, then one square bracket, then another square bracket, and single quote, see x1, x2, sorry, like this, single quote x2, give the column names, single quote x3. Let's say I want to extract first 3 subjects. See here, I got now x1, x2, x3. This is the CGP, grade of all the students in 3 subjects. Let's say x1 is C programming, x2 is Python programming, x3 is probability and stats subject. Now you can save this as some variable. Let's say I will write it as x3, okay, like this. So x3 is now sort of a matrix which has 2000 rows and 3 columns. Now there is one terminology. When we save any column or columns of a data frame, the resulting data type x, this here x3, this is called Pandas series. It is not a data type like we have arrays or lists in Python. It is called Pandas series. Now to convert this into, suppose, arrays, we need to do something. When I write x3, then dot, there is one function within this Pandas series variable x3 is called toNumPy. Okay, so you see, when I write x3 dot toNumPy, we now got the usual matrix or the array. Okay, is a multi-dimensional array in which you have 3 columns and 100 rows. See the difference. If you directly write df and extract 3 columns from data frame, you get this type of data frame, data type. This is the Pandas series. Pandas series has one issue, that we will see the various machine learning algorithms we need to run, like linear regression. It accepts data as array, not Pandas series. So it will be very useful later on. Now we may have one question. Suppose we want to extract all the grades, let's say x1, x2, x3 up to x40 and CGPA, because this is our input in the linear regression. We would like to extract this separately, these columns, and this average CTC LPA as a separate array. How to do that? So let's see. Okay, we'll write df. There is one particular function within this. It's called LOC, data frame.loc. So this LOC is basically a location based identifier. It tells Python that we need to extract, suppose, the range of particular columns or range of particular rows. So now the syntax is like this. So we first have the square bracket again after dot. Now since we want all the rows, so this column is used to identify that, it means include all the rows. But for columns, we want all the columns from x1 to x40 and CGPA. So we will start one more square bracket. Then we want to extract all the columns from x1. Then you see this column and till CGPA, again column. Then close this square bracket, one more. Just wait, there is some error. Oh, sorry, we don't need to include here one more square bracket. It's like this. Okay, now see, I repeat here, we have written df.loc, means location identifier, and the first entry actually will dictate how many rows we have to select. If you want to select all the rows, we just enter column. Then the second entry is about which columns we want to extract. I want to extract all the columns. You see the original database data set is here. So I want to extract x1 till CGP. I don't want to extract enrollment number also for timing. So I have done it here like this. Select all the columns from x1 till CGPA. That is x1, x2, x3, x4 up to x40 and CGPA. You see, we got it. And let's now define one variable input and select it like this. Okay, now this input is what? It is a Pandas series. You see, it is a Pandas series. It is not a standard database. Now we can write this input dot to numpy. It means convert this Pandas series into a numpy type of array. You see, now we got this sort of a matrix. It is same matrix. I mean, it has 42 columns and it will have 2000 rows. And we will see very soon that machine learning algorithms will be able to access these rows as one entity. Suppose the row 1 is, what is row 1? Row 1 is are the grades of student number 1 till this point and CGPA. Row 2, grades of student number 2 and CGPA, so on and so forth. So each row is sort of input with respect to this machine, linear regression. So this x vector is actually the row of each row of this input. Or in other words, if you go to the database, suppose x11, x21, xn1, y1. So y1 will be the CTC, but from x1 to xn, this is what the row values are about. Now suppose you want to extract the output. Let's say I will write output is equal to df. Now here we don't need to do any location because we know what is the output. The output is this. Let's go back here. It is average CTC LPA. So this variable, control V, Okay, so now let's see the output. It is again a Pandas series, and you can write here 2 numpy, okay, which got converted to this. So if we go back, so input we can now write here as x input. So now x input contains the grades and CGPA of all the students in standard array form, and let's save this output into y output, and this y output now contains the average CTC of all the students. Now we are actually preparing for running the machine learning algorithm linear regression. We have now input separately stored in sort of a matrix, and we have the output in form of an array. I think the video is already 20 minutes above, so nearly 20 minutes. So I think I will make a separate video for linear regression, which will be follow up lecture of this. Thank you.